Hello, everybody. So today we are going to be starting into a new chapter and section. And that chapter and section is chapter 5. And this is actually going to cover sections 1 and 2. And in these two sections, we are going to talk about solving linear inequalities by using addition, subtraction, multiplication, and division. So first of all, we need to talk about what an inequality is. And so we are used to solving equations, something of the effect like 2x equals 10, right? So that's easy enough to solve. And it's an equation because it has an equal sign. Well, what we're going to be talking about now is how to solve what looks like equations, but they don't have equal sign. They have what we call inequality signs. Inequality signs are what you see listed there. There's a greater than, which is the first one, a less than, a greater than or equal to, or a less than or equal to. And so the easiest way that I found to remember, because it is very easy to get them mixed up, the easiest way that I found to remember of which sign is which is to look at your fingers. Now I'm going to kind of turn to the side here because you got to look at the camera. But if I take, this is my left hand, all right? And if I take my left hand and I look at it, you can see left hand creates a less than sign. So if I hold them out in front of me like this, I can see that my left hand is creating a less than sign. And again, it's a little bit tough for you to be able to see this because we're obviously in remote, but that's the way that I remember it. Your left hand makes a less than sign. So moving forward into the first type of equation, or inequality in this case, you can see that I have this inequality that says d minus 12 is less than 8. I need to solve for d. And in order to solve for d, I need to get rid of whatever number is with d. In this case, minus 12 is there. So I need to undo subtracting 12 by adding 12 to both sides like this. Now, in doing that, these two 12s cancel, and I'm simply left with d, and then 20 on this side, and then this inequality sign just drops down. And so you can see that I have d is less than 20. Now, what you're going to find is these are very, very similar to solving equations. There's only one additional step, which I will show you here in a second when it comes up. But for adding and subtracting, these are done exactly the same as you would if you were solving an equation. So I'm going to draw a line again where the inequality sign is. I'm going to look at my variable. I'm going to decide what is happening to the variable. In this case, it is being subtracted by 14. So I'm going to add 14 to both sides. And those two 14s cancel. I'm left with y on this side. Negative 19 plus 14 is negative 5. And then the sign just drops down. So our answer is y is greater than or equal to negative 5. Now, moving on to number 3, this one is going to be done in a similar fashion. We're going to draw our line down from the sign. We're then going to identify the variable, and we're going to see what is happening to the variable. In this case, the variable is being added to 26. So we need to undo the addition of 26 by subtracting 26 from both sides. When we subtract 26 from both sides, these two cancel. I'm left with my variable here, and 13 minus 26 is negative 13. And then the sign is going to drop down. Now, what my suggestion is, when you get answers like this, where the variable is not listed first, I would like to see you flip-flop everything around so the variable is listed first. And you'll understand why in another video when I explain to you how to graph these, but it is much easier to graph when the variable's first. So we're going to flip-flop the variable around, which means the r is going to go to the left, the negative 13 is going to go to the right, and this is very important. The inequality sign also has to flip-flop. So if you remember, maybe back in the last year, the year before, you were taught inequalities, maybe even further than that, maybe back in elementary school. And they said, think of these inequalities as like an alligator or something. Obviously, I'm not an artist, right? But that alligator is eating the variable, right? The variable's the bigger one, okay? So what I'm going to have to do then is, since that variable is being the one that's chomped on, whenever you flip-flop these equations around, the variable also needs, the inequality sign also needs to be flip-flopped. And so this is much easier to understand. It says r is greater than negative 13. So that means we need numbers bigger than negative 13. So I would like you to flip-flop them around so the variable is written first. The next one is a little trickier. And the reason why it's trickier is, if you notice, there are variables on both sides of the inequality. These are a little bit harder just because there's more steps to them, but they're not terrible. I'm going to draw my line where the inequality sign is. I'm then going to get all the variables to one side. Now, my suggestion is to move the smaller quantity. So in this case, I'm going to subtract w from both sides. And so when I subtract w from both sides, that cancels. The 4 is still left behind. It's still a greater than or equal to sign. And then what we have is we have 2w minus 1w gives us 1w. And so there again, this is the same situation as we had in the last problem. The variable is not first. I would prefer that you write the variable first. So we need to flip-flop everything around. The w and the 4 are going to trade places, and the sign is going to flip over. So keep that in mind. The alligator was eating the 4. When you flip it over, when you move the w and the 4, you still want the alligator to eat the 4. Therefore, it is flipped over. And then that is your final answer. W is less than or equal to 4. Okay, so I have one more problem for you. This is going to be a word problem. And we're going to use inequalities. We're going to write and then solve an inequality to solve this problem. And it says Annie has $65 to spend at the mall. She bought a bracelet for $18 and a belt for $16. If Annie wants a pair of jeans, how much can she spend? And so the thing to keep in mind here is that she is capped at $65. She has no more money to spend. Now, we do not know how much the jeans cost, so we're going to call the jeans X, and X is going to be the cost of jeans. Okay, so the first thing we're going to do is define our variable. The next thing we're going to do is we are going to write our inequality. And so she has already spent $18 on a bracelet, and she's also spent $16 on a belt. Then she wants to buy a pair of jeans, which we do not know what the cost of that is. However, we know that she is capped at $65. So the 18 plus the 16 plus the X needs to be less than or equal to 65. Okay, now just because she has 65 doesn't mean she has to spend all of the money. That is the absolute ceiling that she can spend. Now from there, to solve this, we're going to add 18 and 16 first. So we're going to get 34 plus X is less than or equal to 65. So you can see I just combined the 18 and the 16 into one number. From there, we need to get the X by itself. So we're going to subtract 34 from both sides. And when we do that, we end up with X is less than or equal to 31. And so what that tells us is she can spend up to $31 on a pair of jeans. So there you go, guys. That's the first day in Chapter 5, Section 1 and 2. I hope everything made sense. And as always, if you have any questions, feel free to email me. Have a great day.